Morning everyone. Today I'm going to explain an important topic from Verilog called Compiler Directives. So let's start. So basically compiler directives are special instructions that are provided to the Verilog compiler, and these instructions are executed during compilation time and not during simulation. Okay. And these instructions help us control how the compiler processes the Verilog code. So in Verilog, all compiler directives begin with a backtick symbol and not a hash like in the C language. And they are mainly used for controlling compilation, simulation, to organize our code, to provide conditional compilation. We'll see what is conditional compilation, to manage global definitions and improving readability, maintainability of large designs. That's why we use compiler directives in Verilog. So there are several commonly used compiler directives, and now I will explain each of them in detail like this. Okay. So the first and most frequently used directive is backtick define. This is used to create text macros in Verilog. So wherever the compiler encounters that macro name, it substitutes it with the value that was defined earlier. Okay, so this is very similar to the hashtag define instruction used in the C language, if you have learned C language. So for example, here we have defined word size, sorry. So here we have defined word size 32. Okay, so whenever word size appears in the code, the compiler replaces it with 32. So we can also define frequently uses string like this, okay, which reduces typing effort and improves clarity. We can also define alias like this, $stop. So there is also an undef directive which can be used to remove a macro when it is no longer needed. Okay, let's move to the next slide. So the next one is backtick include. So include allows us to insert the contents of one Verilog file into another during compilation. So this is extremely useful in large designs which contain multiple modules and common definitions. For example, we can include a header file that contains global declarations or parameter definitions or frequently used macros. So this works just like the hashtag include directive in C language. So it helps us in code reuse, modularity, and easier maintenance. Okay, we'll run this example on the tool. So at this point, you might not be able to understand, but in the tool session, when we'll run all these examples, you will understand what's actually happening. Okay. The next one is time scale. So this directive is used to specify time unit and time precision for simulation delays, and the format is this: first backtick time scale, then time unit, then time precision. So the time unit specifies the smallest unit of time used in delays such as 1 nanosecond or 10 picosecond, and the time precision controls how delays are rounded off, commonly 1 picosecond or 100 fermisecond. Okay. A common example is this time scale 1 nanosecond by 1 picosecond. So if we write delays such as hashtag 0.5, 0.49, 0.01, so the simulator rounds these values according to the precision. So in this example, delay values less than 1 picosecond get rounded and events may appear at the same timestamp. So I have also shown the output over here that, okay, event are shown in the same timestamp 1, 2, 3, right? So this helps us accurately model hardware timing behavior. Now, conditional compilation. So it's a very useful feature in Verilog. It allows us to include or exclude portions of code based on certain conditions. The commonly used directives are this. First one is ifdef, complete the block if the macro is defined. Then ifndef, completes the macro, it completes if macro is not defined. Else means alternate block, else if condition. Undef, okay, undef here. Undef removes the macro, and define defines the macro, and if end of condition. Okay. Um, so this is the example. So in this example, if debug is defined, the extra debug information will be printed like this. And if debug is not defined, normal mode message will be displayed. So this is mainly used to enable debugging features without modifying the main design code. Okay. Here output I have shown that in debug mode, extra information will be printed. If debug is not defined, output will be normal mode. Okay. Then comes default net type. So this directive controls the default data type of nets when they are not explicitly declared. Okay. For example, this default net type wire, this means that if we forget to declare a signal, the compiler will automatically treat it as a wire. Okay. However, this can sometimes hide mistakes such as spelling errors. So to avoid that, we can set default net type none, like here. Okay. So in this case, the compiler throws an error if any signal is undeclared. Okay. So this helps us catch accidental net creation and enhances code safety. Okay. So I think this is our last slide. So to summarize, compiler directives are instructions processed at compile time. They start with a backtick. They help in defining macros, including external files, controlling time formats, conditional compilation, and managing net types. They improve the flexibility, readability, and modularity of Verilog designs, and they are widely used in professional chip design environments, especially when we work with large and complex modules. Okay, so that is all for today. See you in the tool session. Till then, bye bye. Thank you for watching.